Yes, in example 14, we are told that show that you can express 3 sine x plus 4 cosine x in the form r sine x plus alpha. And according to what we have understood in the previous video, or on page 71, or on page 85, still on page 71, we have known that we can express r sine x plus alpha to be equals to r sine x cos alpha plus r cos x sine alpha. This one is just highlighted up there, simply highlighted up here. So r sine x plus alpha is r, whatever it is, r, if you expand this according to the addition formulae. At that point, therefore, we can say that let 3 sine x plus 4 cosine x to be equals to, 3 sine x plus 4 cosine x to be equals to. So let 3 sine x plus 4 cosine x to be equals to r sine x cos alpha plus r cos x sine alpha. Why are we saying that? Now that we have expanded r sine x plus alpha to be equals to r sine x cos alpha plus r cos x sine alpha, this side, and you're supposed to show that you can express 3 sine x plus 4 cos alpha in this form, and this form itself is expressed this way. So if this form is expressed this way, so we are simply saying that show that 3 sine x plus 4 cos x can be expressed in terms of r sine x cos alpha plus r cos x sine alpha, this part. So if it is possible to show 3 sine x 4 cos x in the form of r sine x plus alpha, and r sine x plus alpha itself can be expressed in this format, then it is also possible to express 3 sine x plus 4 cos alpha to be equals to 3, or rather r sine x cos alpha plus r cos x sine alpha. At that particular point, you can already see that if this is the first term, is going to be equals to this term. So 3 sine x is going to be equals to r sine x cos alpha. Divide by sine x on both sides, divide by sine x on both sides, so that we can clearly see that r cos alpha is equals to 3. Consequently, the second term is also going to be 4 cos x must be equals to r sine x, must be equals to not sine x, r cos x cos sine alpha, yes, the second term, sine alpha cos x. So what? So that when we divide by on both sides by cos x over cos x, then we have our r sine alpha to be equals to 4. Interestingly, when we talked about trigonometric ratios and identities, we highlighted somewhere and we said sine x over cosine x can be given as tan x. That we know. And because we have sine alpha here and cosine alpha here, it means therefore the r sine alpha over r cosine alpha, which is easily the tangent of alpha to be 4/3. So at that point, we can easily identify the value of alpha. So we just pick our calculator. There's a certain angle alpha whose tangent is 4/3, and that angle is 51.3. You will evaluate using your calculator. 51.3 degrees to 1 decimal place. But of course, let's see something. If we talk of what? If we talk of a trigonometric angle, an angle here, and let's talk about this being alpha, and the tangent of alpha is opposite, which is 4, over adjacent, which is 3. It follows that according to Pythagoras, this is 5. Why is it 5? That is basically 5. And if this is 5, this is 5, let's first of all agree that. And because we have realized that alpha is 51.3 degrees, we are already seeing 3 was r cos alpha. So we can as well write this one as r cosine alpha. And r sine alpha was 4. We can as well write this side as r sine alpha. And interestingly, we can already employ that r squared cos squared alpha, if we square this side, plus r squared sine squared alpha is the same as writing 3 squared plus 4 squared. And we can see r squared cos alpha squared alpha plus sine squared alpha in the bracket is equals to 9 plus 16, which is 25. But who doesn't know that the cosine squared alpha plus the sine squared alpha is 1? So easily we are realizing that r squared is 25. And of course, r, because we are told r is greater than 0, in a certain point we are told that r is greater than 0, then we have to identify the square root of 25 with that in mind, and we can already tell you r is equals to 5. So we can simplify this and have, because you are told, show that you can write 3 sine x plus 4 cos x in the form of r sine x plus alpha, and we have found both of them. So therefore 3 sine x plus 4 cos x is exactly equals to r, which is 5, the sine of x plus alpha plus 53.1 degrees. And we have just been able to establish or to write 3 sine alpha in terms of 3 sine alpha plus 4 cos alpha, cos x rather, 3 cos x plus 4 cos x in the form of r sine x plus alpha, whereby we have found both r and alpha in this very good format. That was example 14, part A, and we have used so much of what we have learned in the previous video. Note that has been shown. We are now going to example 14, part B, and that is also going to be very awesome. All right.